Now for this lesson and for the lesson that follows, we're going to be referring from time to time to this library that I've included in our Program 2 Expressions folder. And the library is called Expression Library, and it's actually a collection of fun expressions. So I want you to launch that library in Acrobat. And while we're here in Acrobat, I want you to select the text tool, wherever it is on your particular toolbox. It may be here on the left, but on your screen it may be up here somewhere as well. At any rate, look for the letter T with the little dotted line box that comes after it. Select that, and that will allow us to move page by page through this document with the page up, page down key. And then when we find an expression that we like, we can just copy that expression and paste it in. We'll be doing this as we move along through the series. But for now, let me hide Acrobat and let me open up the Wiggle project. And let's talk a little bit about random noise. Random is one of those great functions in expressions that is useful in many, many ways, and we'll continue to use it throughout the rest of the series. Let's talk about exactly how to work with it, and let's start by randomizing something fairly basic, like the transparency of our Earth layer. I'm going to enable an expression for our opacity by option-clicking on the little stopwatch, Alt-click on Windows, gives us an expression, and now we have a choice. If we know what we're doing, we can just type anything that we want to in this expression field, because obviously this is just text and we can edit it like any other text. And if you know what to write, you can just write stuff in there on the fly. But if you don't know what to write, if you're not sure exactly what the syntax for a particular expression operation might be, there's this little pop-up here next to our pick whip. And if we click on that, you'll see it gives us a list, which is actually a library of correct syntax. Each of these pop-outs has several examples of bits and pieces of expression code. And if you're not sure what the syntax is for something, or what an operator is for something, you can just look things up here in this library. These are not objects. This isn't object-oriented programming or anything like that. This is nothing but an auto-typer. So if we look into our random numbers property, there's a whole bunch of ways to create and modify randomness, including picking a random seed, which only works in certain limited situations. We're not going to bother with that right now. And there's a whole bunch of other types of noise, etc. But we just want to deal with simple randomness, and the most simple randomness we can choose is this one right here. Random, parentheses, close parentheses. Let's select that. By default, if we hit the Enter key, we'll make our layer essentially go away. And if we look at our opacity value, you can just see it on the left-hand side of the screen here. It's set down to 0%. If we push the space bar, it never really changes from 0, and only every once in a while gives us 1. The reason for that is by default, if you don't modify the value that random gives you, then it's going to automatically generate random values between 0 and 1, which can be useful in certain situations. A transparency value of 1% is not much better than a transparency value of 0% as far as the actual pixels on screen are concerned. So we want to up that value. And since opacity has a range from 0 to 100, that's how this random parenthetical value works. Any value that you enter in here, let's say 100, will now generate on every frame a random value between 0 and this number. Okay? So now you'll see our Earth has kind of appeared again back up here. If we hit the space bar, every single frame will generate a new random opacity value for our Earth. It kind of flickers in and out as it goes. Pretty cool. Now, expressions are flexible enough that you can accomplish certain tasks in different ways. For example, what if we wanted to create a range of randomness that wasn't from 0 to 100%, but was maybe from 80 to 100%? Well, if you know the syntax, you can just type in 80, 100 inside our parentheses here, and now that'll generate random values between 80 and 100. So no value on our Earth up here will ever dip below 80, and of course no value will ever go above 100. Which it wouldn't anyway, because you can't have an opacity level above 100. But by typing 80, 100, we're basically constraining the randomness within that range. But if you can't remember this, or if anything comes up where this isn't the best way to set a range, and I'll show you an example of that a little bit later, you can actually be a little more brute force with this and just take advantage of math. And I just want to show you this, not because it's the best way to do it, but because you don't always have to know the exact syntax to get the same results. Since the random range we're looking for is a range of 20, and that range is from 80 to 100, but we're looking for anything from 80 to 100, a range of 20 values that exist between 80 and 100, you can just type in random 20, and that sets our range, and then adjust the start point of that range by hitting plus 80. So it'll generate random numbers from 0 to 20, and then it'll add 80 to whatever number it comes up with, and we'll get exactly the same results. We will get random values between 80 and 100. Like I said, I'll show you an interesting reason why we might want to do this a little bit later. Randomness gets very slightly trickier when we get into multiple dimensions. Opacity is obviously a one-dimensional property. We're just varying one number. But let's turn off the expression for opacity, which will just keep us at 100% the whole time. And instead, let's solo our scale property with the S key, and let's apply some randomness to scale. Let's see how we do that. Now we know all we have to do is type in the word random, followed by some numbers. You might be tempted to just say, well, let's generate random scale values between 0 and 100, and you'll hit enter, and an error will kick up. You're going to see this error a lot, probably, or at least this error dialog box, because this is how After Effects helpfully lets you know that you haven't written a good expression. It's telling us that our expression must be of dimension 2, not 1. Which is pretty much what I just led up to by saying scale is a two-dimensional property. It's got x and y values required to describe the scale of an object. And by default, those values are not linked in After Effects, so we've got an error in our expression. Let's click OK. Now, earlier, I hinted at the idea of arrays. An array is a way of representing a group of numbers that represent multiple dimensions. And the most simple array in expressions is simply a bracket followed by a number, followed by a comma, followed by another number, followed by another bracket. And yes, they have to appear inside these parentheses like this. So you end up with these sandwich parentheses and brackets. Anytime you see a number inside of brackets like this, it's either defining an array or referring to an array. Okay? But in this case, this is a two-dimensional array. This is exactly what we did a little bit ago when we were accessing only one parameter of scale, when we were adjusting the rotation of our dial and trying to only scale along the x or y axis. But now we're generating random values that occur in multi-dimensional space, x and y. So now that we've got that in there, we hit enter. And sure enough, let me bring down our Earth layer so we can see it. If I now tap the space bar, you'll see every single frame we're generating wildly random values here. Okay? Now what if you want to constrain an array to a certain number range? Well, it gets a little bit more complicated, but not too much if you think about it. A second ago, without the brackets, we typed in 80, 100, and that constrained things between a value of 80 and 100. Well, now we're dealing with a two-dimensional array, so all we need to do is put two arrays in here. One array that defines the low end, one array that defines the upper end. So if we put another bracket in here, type 80, 80, close brackets, comma, we've now defined within the parentheses the start range and the end range, and we've defined those as arrays. So we've got a minimum value of 80 wide and 80 tall, and a maximum value of 100 wide and 100 tall, and now generate random values that just sit there and jiggle between 80 and 100 in both dimensions. Now, of course, these number values that I've plugged in here are completely arbitrary. There's nothing that says it has to be anything from 80 to 100 or whatever. I just plugged these in just to prove a point. You can enter any values that you need to enter that make sense to generate this kind of information. Okay? So we've got an Earth up here that's jiggling in multiple dimensions. What if we wanted to constrain the jiggle here so that it was randomly generating a scale value, but it was generating the same scale value for x as it was y? So that our circular Earth randomly changes size, but doesn't randomly change its aspect ratio to give us this kind of squished effect that we're getting right now. Well, random just generates a random number every time you ask it to. So we can't force it in a single line down here to generate the same randomness twice. We can't do it with one line. We have to get a little more complicated in our expression. And this is where things might start getting a little scary for you, because I'm going to introduce some things like variables. But I promise these aren't really that hard to work with, and they can really open up a lot of opportunities that we'll continue to work with throughout this lesson. So let's take this range. Let's say this random value of 80 to 100 is fine, but I want to constrain that 80 to 100 along a single axis. Okay? So this is working for generating random values from 80 to 100 in two dimensions. How do we just get both dimensions to use the same dimension? All right? Well, this is going to be our variable instead of our finished expression. And a variable is a line of an expression that simply defines a calculation or a value that you're going to use later on in the expression. A variable can be named anything that you want it to be. Very commonly, you'll see people use just letters. X equals this, Y equals that. And that works fine, and if you're comfortable with that, go for it. But to a lot of people, that ends up looking a little too much like algebra and gets people all flashing back to a negative space in high school. So feel free to use anything that you want to, really, as long as it's not a word that coincides with something else in the expression language. You can get away with just about anything. We could say, if we wanted to, duck equals random, blah, blah, blah. So we've defined this value as duck. Duck is going to be generating this two-dimensional random matrix that'll generate in 2 dimensions values between 80 and 100. That now has become duck. Later on, if we call duck in our expression, it's going to return these values generated by this little calculation here. All right? I'm going to need to expand my expressions window out a little bit because we're going to need a couple of lines here. Anytime you're working with a multi-line expression, you might see a few different things that you wonder about. First of all, anytime that you've got multiple lines in an expression and you need to carry a calculation down to the next line, you want to end a line with a semicolon. All right? So that tells us, hey, there's more to come on the next line. Now, in addition to that, very often in pre-made expressions, as we'll see in just a second, you'll sometimes see a couple of slashes followed by a description of something. Like we could say, this sets a random value for duck. Now, this is nothing more than notation. Let me get rid of my parenting panel here so we can have a little more room to work on our expressions panel. All this is doing is reminding me why I wrote this, okay? Anything that appears after slashes will be ignored by expressions as far as the calculation is concerned. It's just there as kind of a note to let you type in whatever you want to help you remember why you wrote what you wrote. This is known as notation. So now that we've generated these script values up here, we're going to turn them into actual useful numbers that can be plugged into scale. The numbers that we need to generate at this portion of the expression are an array, so we know we're going to start with a bracket, right? If we wanted this calculation up here to return values that would be identical to the original calculation, we would type in duck bracket 0 and duck bracket 1. We need a second bracket there to close our initial brackets. We got brackets inside of brackets here. The 0 refers to the 0 portion of the array up here that's being calculated. The 1 refers to the second portion of the array that's being calculated up here. Remember, I referred a second ago to programmers always liking to start counting at 0. So you end up with 0, 1 when you have a two-dimensional array, and it'd be 0, 1, 2 when you have a three-dimensional array for 3D position or 3D rotation. Okay? So in this case, if I do duck 0 and duck 1, I will basically be passing the values that are generated up here through to our scale values and getting exactly the same results that I got before, right? But if instead of that, I type in duck 0 for our x values and duck 0 for our y values, it's going to bring the same array value that's generated up here down into this array and plug the same value into both places. And now we're going to get a uniform random value generated in both x and y. Now, if this feels like we're getting a little bit ahead of the game, don't freak out. We're going to do some much simpler variable stuff in just a bit. But this nicely fit into our discussion of randomness, so I wanted to point this out right now. This is a little more complicated than I'd planned on getting to at this point, but nonetheless, it kind of fits in the context of our random number generation. Let me just fine-tune this expression a little bit. Let's go from 90 to 100 instead of 80 to 100 so that we have a more subtle expansion up here, not quite as extreme as we had before. So values between 90 and 100%. That's pretty good. Okay, and let's see what else we can do with randomness. Let's bring our Earth back to the center here, and I'm going to twirl closed my Earth movie. We're done with animating its scale now. And let's turn on our ArtBeats numbers layer here. You won't see anything in the window up here because we're not actually over the portion of the ArtBeats movie that has video in it. So let's jump back here and you'll see we've got the numbers of a clock ticking by, which is fine. What if we wanted to turn this movie of numbers into a random movie of numbers? In other words, we wanted to randomize the time of this clip. Well, you can do that with randomness as well. We have approximately a 2-second clip here. Let's see what we got, 1:25. So almost 2 seconds. That's fine. Well, since we want to manipulate time, the first thing we want to do is turn on time remapping, which is at the bottom of our layer menu here. Enable time remapping. Then we want to stretch our layer out and hit the letter R really quickly twice to solo our time remapping keyframe so we can see what's going on here. And we're going to enable an expression for time remapping. Let me option click there. Now, we want to randomize time, and time is a very specific numerical value in After Effects. It's kept track of not in frames, but in seconds. So whenever you're doing any kind of operation on time, you want to make sure that you're doing that operation in seconds. And we have ourselves just about 1.8 seconds of random time here. So let's just generate a quickie script, random 1.8, and that's it. Hit enter, and now it's randomly going to choose numbers on each frame anywhere from 0 seconds to 1.8 seconds and generate a completely random array of numbers that we see here instead of the linear countdown that we were getting before. So you can randomize time if you like. What else can we randomize? Well, let's add a text layer to the mix. Let me jump home here, and we'll add a new solid, make it the comp size, and call it text. Hit enter. And now let's apply effect, text, basic text to this solid. And let's type in something meaningful and poignant like these uncertain times. Keep it centered. Let's pick a better font than Arial Narrow. Something like Lithos. Yeah, it's got more of an ancient Greek look to it. Definitely more timeless. Let's set this to white. We'll scale it up a bit. We'll adjust the tracking and the line spacing so that it's a little bit more together. And let's move it up to this portion of the screen. Okay, that's the last we'll need to adjust our text. Let me close that down in the effects palette. Let's add another effect to this. This time I'll bring up my effects palette and we'll type in really quickly here DIRE, and that gives us directional blur. And we'll just double click that to add that to our layer. And I'll hit Command 5 again, Control 5 on Windows to make that go away. I'm going to quickly set keyframes for both of these properties and then hit the U key so that we can see only those properties down the timeline. And now let's set some expressions for these two properties as well. I'll set an expression for blur length, and I'll set an expression for direction. We want to choose a random direction for our directional blur, and we want to have the full spectrum of possible directions. So let's just type in random 360 with obviously parentheses, and that'll generate random numbers from 0 to 360, thus choosing a different random direction with every single frame. And a quick page down shows us that we've accomplished that. You won't notice anything in the comp window yet, however, because we haven't actually set a blur amount. Let me go back to frame 0 there. And twirl closed our direction property now, and let's concentrate on blur length. Here we're just going to set a random value as well. Let's just type in random 100, for example, and hit enter, and let's see what that gives us. Well, what it gives us is a blur value that will randomly point itself in a given direction and randomly choose a given length. Right now, our first values are a blur value of 88 and a direction of 221.9 degrees, and we go forward a frame. And you'll see our degrees have changed a little bit, and our amount of blur has changed a little bit. And there we've got less blur. There we've got much less blur. Now we've got more blur. If I hit the space bar, or better yet, generate a RAM preview of this, you'll see that it's kind of coming in and out of focus. You can sort of read it when it's together. It's definitely chaotic. It's definitely bouncy and grungy, which is kind of cool. But it's a little bit overdone. It's a little bit too much. Now, a bit ago, I told you that there was another way to constrain values other than typing one value followed by a comma and then another value. I told you that you could constrain values by actually adding or subtracting values from the final random calculation. Let's see how we can use this to our advantage down here in our expression. We can take advantage of the fact that you can't have a negative blur and use that to great effect. In other words, any value that we plugged into our blur amount here, any value that dipped below 0 would just be clipped at 0, all right? So if I generated an expression that came up with a value of negative 50, I wouldn't have a negative 50 blur. I would just have a blur of 0. Negative 100, I'd have a blur of 0. Negative 1,000, I'd have a blur of 0. So we could take advantage of that by generating a much bigger random number and then subtracting something that would kind of clamp our values down a little bit. Let's see what I mean. If I'm happy with the range of 0 to 100 as far as length is concerned, but I only want to have a likelihood of a blurred frame every 10 frames or so, then let's type in a value of random 1000, which will now generate on every frame a random number between 0 and 1000, and then subtract 900, okay? That means for 9 out of 10 frames, on average, this expression will be generating a number from 0 to 1,000 that's less than 900. And when we subtract 900 from it, we'll end up with a negative number, meaning it will return a value of 0. What this means is, for 9 out of 10 frames, we're not going to see any blur. And then, boom, a little blur will pop in a random direction, and then no blur, and then, boom, a little blur will pop in another random direction. Let's see what that looks like with a quick little RAM preview. Much better. We're just getting a little pop every now and then as if the image is jumping out of focus, like a little flash frame. This can be very useful. So by using this method, not only can you randomize how much of something you get on screen, but you can also randomize when it shows up as well. So here we're basically creating randomness that only shows up every 10th frame or so, which certainly has its purposes. But what if we actually wanted to animate the amount of randomness? What if we wanted to start out with no randomness at all and then get really random and wiggly and then settle back down again and not have any randomness at all again? Well, that's a job for keyframing, obviously. But I can't keyframe anything down here in my expression. If I try to set a keyframe or even adjust a value for my blur length, I'm going to get a warning message asking if I want to turn off the expression. Well, no, I don't want to turn off the expression. I want to generate values that I can keyframe. This looks like a likely place to want to keyframe a value, right? This value right here, after all, is what I would want to be animating from 0 up to like 100 and back down to 0 again. Well, how can I do that? Well, the answer is found up here in our effects palette. After Effects has a category of controls here called expression controls. You may or may not have experimented with these. If you have, you might have scratched your head and said, these don't seem to be doing anything at all to my layer. Truth be told, these don't do anything at all to your layer. Apply any one of these and nothing will change on screen. No pixels will change on screen whatsoever. We saw a pixel change there, but that was only because we clicked out of the expression here and now it's generating a random value from 0 to 100. But the slider didn't contribute anything to the pixel change of the layer, as you can see if I turn it off and back on again. But what we can do with this control, which doesn't affect the pixels on screen, is we can animate this control and then we can tie our expression to this control. So we can, in effect, by using a slider control, animate or keyframe an expression. Let's do that here at about 1 second into our comp. We're close to a second, so let's just page down to 1 second and set a keyframe for our slider at 0. And we'll go about 2 seconds in or so. And we'll set our slider value up to somewhere close to 100. It doesn't have to be exact. Now if I hit my U key again really quickly, a couple times, you'll see I've got a couple of keyframes now for this slider control. We still aren't having any effect on our expression. Don't expect this to have any effect on our expression until we hook it up. I'm just setting keyframes of values that we're going to be using. So I'll jump out to maybe about 4 seconds and set another keyframe for our slider, and then jump out to 5 seconds or so and set this value back down to 0. So now I've got a keyframe slider that's not affecting the pixels on screen. But I want the values that I'm generating with this controller to actually control our expression. So if I twirl open our expression here once again, I've got random 1000, right? How do I type in an expression that will now access this effect control? And the answer is you don't have to. All we have to do is select this number in here. Just select the number 1000. And with this number highlighted, if we use our pick whip and drag the pick whip up to the slider control and let go, After Effects will type in the correct expression for us. And now we hit enter and you'll see the random value that's generated is coming from the effect slider control on the current layer here and the parameter slider. Okay, so it's pretty easy to read, just like any other expression that we've dealt with. But now if we RAM preview this, you'll see that for the first second we have no blur at all. Then we smoothly transition from a little bit of randomness to a lot more randomness for a couple of seconds, and then smoothly back down again to no randomness at all. And the results are a lot more organic, a lot more interesting. You've never been able to keyframe randomness in After Effects before, not even with the Wiggler or with Motion Math. Not until Expressions came along did you have keyframeable controls over this kind of stuff. Really cool, really powerful. So those are some tricks for working with randomness as far as pure randomness is concerned. But randomness on its own has only limited uses because this kind of noise may be fun for these kind of grunge effects or these kind of completely random effects that you see on screen, these noisy effects. But if you want something a little smoother than this, then you don't want to use random. You want to use a more periodic randomness that smoothly transitions from random value to random value. Otherwise, you're looking for a wiggle. So let's close down this composition and open up the Perlin noise comp real quick, or just sit back and watch, because all I'm really going to do is page through this comp as if we were watching a PowerPoint presentation, and we're going to talk a little bit about how Perlin noise is generated. Now, Perlin noise was named for a very clever man named Ken Perlin, who works at the Media Research Lab at New York University. He came up with a way of describing noise that's very commonly used now in computer graphics. The idea behind it is basically this. You represent a wave on a two-dimensional grid, just like we use in After Effects, a coordinate system, right, that starts with a 0, 0 point. We map out points on that grid, and you map them out in a predictable fashion like this, and you get a sine wave. Now, this particular kind of wave, the amplitude is measured from a center point, and the wavelength is what's considered from trough to trough, or from peak to peak. Let me page down here. In the case of pure randomness, there's no wave to it at all. Basically, on each and every frame, a new calculation results in a new random number. It's up to the programmer to determine how these random numbers are calculated. It can be any kind of system that generates random numbers, and they can be a Gaussian distribution or just a completely random distribution. Doesn't matter. But randomness is like the opposite of a predictable wave. Randomness is purely a random number with every single frame. What Ken Perlin did is take this kind of random calculation and spread out the random calculation over a series of frames, so that instead of calculating it every single frame, it actually calculated, let's pretend that between frame 1 and frame 2 now, we have a few extra frames in here, and would then connect the random frames that were generated with a smooth line. Basically, smoothly connect between the random values, thus resulting in a random, unpredictable wave. Pretty simple. In the case of this kind of randomness, the amplitude is measured in the range of possible random values. So an amplitude of 1 would give us random peaks and troughs between 0 and 1. And the wavelength is basically considered the measurement distance between each random sample. Okay? So, in a case like this, your first Perlin noise pass would involve a pretty high amplitude and a pretty low frequency. In this example, we've got an amplitude of 128 and a frequency of 4. Don't worry about those numbers or what they mean. But add to that an amplitude that's half the height but twice the frequency, and you get a slightly shorter but slightly wigglier line. Do that again, half the height, twice as wiggly a line. Do that again, half the height, twice as wiggly a line. Do that enough times, and then mix the results together, and you get basically what's known as Perlin noise. Now, these are all two-dimensional bits of noise. We mix them together, and all we would get would be a wigglier line that wouldn't look like much. But if you extend that out into 3 dimensions and represent those 3 dimensions with x, y, and z represented by pixel values, then you essentially get an interesting kind of noise. In this case, we get this blobby look that you see here. Go a page down. This is an example of twice the frequency, but half the amplitude. You'll notice it's a little lower contrast than the previous one. Once again, this is twice the frequency and half the amplitude. And this is twice the frequency and half of the previous amplitude. It's getting less and less contrasty. This is twice the frequency and half the amplitude, until we're finally at a noise level that we can barely see because the detail is so fine and the contrast is so low. There comes a point in this kind of noise system where the level of detail just doesn't need to get any higher because you can't see it. Combine all of these together, add them together using a transfer mode, and you'll get what should look fairly familiar to you as basic fractal noise. All right? This is how fractal noise is calculated. We'll be looking at the fractal noise filter in great detail in the next set. But when you're talking about levels of complexity in fractal noise, you're talking about layers of calculation that added together result in this kind of noise. All right? Any type of filter that generates fractal noise, the clouds filter in Photoshop is a great example of that, is calculated using the basic math that I showed you right there. So what does this have to do with wiggle? Let's close this down and open up the wiggle composition. And let's try, just for laughs, wiggling our moon layer that we see up here. So let me select my moon. We want to wiggle its position. I'm going to set an expression for positions by option clicking on our stopwatch. And let's type in a new expression. And that expression is wiggle, open parentheses, just like randomness. Now, what numbers should I type in here? Well, don't just type in a value, because that's not going to do you any good. If we type in 100 and then nothing else, it's going to plug in a bunch of other default values, and you're not going to get the results that you want. There's going to be several numbers inside the parentheses separated by a comma. The first number is the wiggles per second. You can think of wiggles per second as the same as frequency in Perlin noise. The next number is the amount of wiggle. How far from our current position in any dimension do we want to go? Let's say we want a wiggle amount of 200. That's the same thing as amplitude in Perlin noise. The next number you can type in, if you want to, is basically the complexity of the wiggle. This is exactly the same thing as the number of layers of noise you're adding together to determine how noisy the wiggle is. You could type in a value, say, of 3 or so, and get fairly smooth noise with a little bit of wobble into it. All right? So wiggle is entirely a Perlin noise calculation. Once you understand how Perlin noise works, you should be able to understand how wiggle works in any situation. The first number that you type in is the wiggles per second. The second number you type in is the amplitude, and the third number that you type in is the level of detail of the wiggle. If you don't feel like typing in that third value, the default wiggle value that's used is pretty smooth, and you can start with just 2 numbers if you like. 1, 200 will give us 1 wiggle per second of a maximum value of 200 at the default detail settings. Well, let's go ahead and bring our other number back in, and we'll hit return. And notice something really important about this. Position is a 2-dimensional property, but we didn't have to worry about that with wiggle. Wiggle is smart enough to know whether or not it's applied to a 1-dimensional, a 2-dimensional, or a 3-dimensional property. And it will wiggle in all properties automatically unless you go out of your way to override it and apply different wiggles to the different parameters, which is a little trickier, and we'll talk about that in just a second. But for now, the results are pretty obvious up in the comp window. We now have our moon basically wiggling around its original position fairly smoothly. Occasional bump in the wiggle. That's from those extra levels of detail we've added in there. But unlike fractal noise, where on every single frame we'd end up in a random position, the randomness of wiggle is smooth. And we get smooth interpolation from position to position, and therefore get a much more natural result.
Another great thing about wiggle is that it augments keyframes. And an even greater thing about After Effects version 6 is you can now go back and add keyframes or modify keyframes even if an expression has been applied to a layer. So let's do that. Let's jump back to frame 0 and let's drag our start point of our moon into the upper left-hand corner here. And I'm now going to set a keyframe for position. Now let's move a little bit later in the timeline and drag our moon down to our second position, and you'll already see that there's a little bit of a disconnect here. This isn't where I set the first keyframe, and as I'm dragging the second keyframe, it's not really connected to my moon. Well, that's because the wiggle is actually being applied after these keyframes that I'm setting. So it's a little bit of a weird thing. You got to kind of adjust for this mentally. But if we move a little further on and click and drag, you'll see we're actually repositioning the source keyframes, and wiggle is being applied afterwards. Now, if this is freaking you out, if this is something that you find difficult to work with, you can always come down here and temporarily disable the expression by clicking on the little equal sign here. That's going to turn off the expression for just a second. And as soon as we do that, you'll see that the wiggle is no longer being applied, and we're free to adjust our path with a little bit more precision. So let me move a little further down the line here, and we'll drag our moon into its final position, which is centered on the Earth. I'll go back after the fact and tweak these values a little bit just to smooth our path out. And now once we've got things tweaked the way we want them, we can come down and rove these keyframes so that the motion along the path is smooth. We saw how to do that in an earlier lesson. And we'll come back over to the equal sign that we just turned off. We'll click on it again. That will re-enable the expression. That'll start things wiggling again. And if we jump back to frame 0 and hit the space bar, you'll see that not only do we have a nice path of animation, but we have wiggling taking place relative to that path. Now, once again, this ability to adjust keyframes that are connected to an expression while the expression remains alive is completely new to After Effects 6. So if during the course of the rest of this demonstration you ever come across an incident where I click on an expression and it throws up an error message, you're probably not going to run into that error message because the After Effects team has solved that problem.
Let's apply a quick expression control effect to our wiggle parameter here. We're going to add a slider control, and I'm going to select the wiggle amount down here in the timeline. That's 200 right now. And with that selected, I'm going to pick whip up to our slider. Now when I hit enter, we're going to have 0 wiggle because our slider is currently set to 0. But if at the beginning of our animation, I crank up this slider value to about 100 and set a keyframe for our slider control at 100, and then jump out to where our moon ends up there on the last keyframe and animate the slider back down to 0. You can see now we can animate the wiggle values exactly the same way that we animated the random values before. So we have an animatable wiggle now with expressions. You see we're wiggling the path at the beginning, but as we get closer in to the center, the wiggle becomes less and less until it ends up at the end and there's no wiggle at all. So incredibly powerful. But as you can see, by doing this, we're kind of confusing things a little bit. Expressions get very, very hard to read in situations like this, where you've got all these parentheses inside of all of these other parentheses, and you got a comma here and a comma here and a period here, and it just gets really hard to read. And if we wanted to pick whip the frequency as well as the amplitude to sliders, this would start to get really, really complex. And if you're already kind of having a hard time remembering which parameter is which, it really helps in situations like this to use an expression that's set up to be a little bit more understandable. If we switch over to the Acrobat file that I asked you to open way back at the beginning of the lesson, and we page down a couple of times, you'll find an expression in here called adjustable wiggle. And if we select the portion that's just in the white part of the screen here, stuff that looks like it was typed on a typewriter, if you select that and copy, on the Mac here we'll Command Tab back over to After Effects. If we now select our expression here and paste, and then expand out our expression window to make sure that we can see the whole expression, we've now pasted in an expression that's a slightly friendlier version of wiggle. And the reason I think it's friendlier is because it kind of explains itself a little bit better. Now this is an expression that uses 3 variables. The variables are just words I made up. Wig freq for wiggle frequency, wig umpt for wiggle amount, and wig detail for, I hope you can figure that one out. Basically, all I'm asking you to do is select any of these values that you see here in any of these variables and hook them up to pick whips. By just selecting these values and hooking them up to pick whips, and they're nicely explained to you, this is the wiggle amount, this is the wiggle frequency, this is the detail of noise. By selecting these values and hooking them up to expression controls with the pick whip, the expression will write itself automatically, but the actual final line of the expression remains nice and neat and easy to understand. So we've selected our wiggle amount of 30, and if I now pick whip that up to our slider here, you'll see it plugs in the slider control information into our variable, but it leaves the actual calculation portion of the expression nice and neat and easy to follow and easy to understand. So that's the way a lot of the expressions in this library that I've provided you actually work. If you just look at the descriptions for the expression, it'll tell you how to work with it. And if you then hook up expression controls to the various variables that are included in the expressions, you'll be able to essentially create little filters that do geometric stuff on screen. It's really an incredibly fun and powerful way to work. All right, so now that I have once again controlled our wiggle amount with our slider here, let's see what we've got going. Well, we've got quite a bit of wiggle here, and then it's fading out. I'm actually going to, at this point or so, actually, let's move a little bit further along. At this point or so, I'm going to go back to my slider and crank it up again because I want to show you something very important about wiggle. Here we are moving around, etc. And we end up there in front of the Earth. What if we want to start out with our moon moving around? And what if we want that moon to be in front of the Earth? Let's click and drag one of our keyframes here so that the moon actually passes in front of the Earth, so we need it to be in front of the Earth during a portion of the animation. But then we want it to go around behind the Earth. Well, of course we could use 3D. That would be one way of solving this problem. Another way of solving this problem is splitting layers. Now that we have calculated our randomness here, we can move along and just split the layer at about this point. This is an old technique I would use here. Shift-Command-D on the Mac, Shift-Control-D on Windows. And then we move the split copy of the layer behind our Earth, and then it would disappear behind the Earth there with the first one appearing in front of the Earth, right? There's only one problem with this approach when it comes to wiggle, and let me page down my way through things. And as I'm paging down, and we're close to that cut point, I'm getting really close now, page down, and at this point in the animation, depending on your setup, you might see a little bit of a jump between two wiggles that have been split like this, where the wiggles don't properly seem to connect with each other. Now, we're not seeing a whole lot of difference between these two wiggles on screen right now, but watch what happens when I just add another layer. I'm going to hit Control-Y and hit OK and just accept the default settings and turn off the visibility of our solid. and our moon is in a different position. If you want to see that position change, I'll just move that new solid layer down a few layers and watch what happens to the moon when I let go. It jumps its position. I'll move it in front of the backmost moon layer. Its position jumps again. What's going on here? Well, this has to do with the concept of a random seed. We've been talking a lot about randomness in this lesson, but one very important concept in the realm of animation is the concept of repeatable randomness. You want to be able, if you're a clever programmer, to generate truly random numbers, but generate the same random numbers every time you calculate things so that you can repeat stuff. If numbers in After Effects were truly random every single frame, you could never go back and tweak the middle 10 frames of a 30-frame animation and have any kind of expectation that the randomness would end up looking correct. And it's really important in Wiggle where the random values are only calculated like once a second when you set a frequency of once a second. Change those random values and you get a different Wiggle path, and your results, as you can see here, can vary tremendously. What programmers do in a situation like this is they add a property called a random seed. If I take this solid that's on the top here, for example, and turn it into adjustment layer, and I apply effect, render, lightning, for example. Don't use the advanced lightning, just pick lightning. And I'll tap the space bar, and we'll see we've got a nice randomly generated fractal lightning bolt. Very cool. If I duplicate this lightning layer and drag the copy down below the first lightning bolt, you'll see we have two identical randomly generated lightning bolts. They're random, but they're identical. If we look down at the bottom of the effects palette, you'll see something called a random seed. The random seed is what programmers use to allow you to vary the predictable randomness that they build into their systems. We've got two random lightning bolts that are being calculated based on some random value. Maybe it's all of the digits that come after the decimal point in pi, or maybe it's some other system that's predictable and repeatable but random. Change the random seed and you add a multiplier to the mix. If we change the random seed of our second lightning bolt to 2 instead of 1, you'll see a different lightning bolt on screen. So all other settings remain exactly the same. The randomness is just being generated based on a different set of numbers, and so we are controlling, by controlling the random seed, the appearance of what happens on screen. So, Wiggle, like lightning, is a random system. Let's get rid of our solid here. Where's the random seed? The random seed in Wiggle is the index of the layer. If you look over on the left-hand side of the timeline window here, you'll see this little number sign, and underneath that, each layer has a number, right? Well, this number is the random seed that's automatically used for each layer. At the time of this taping, there is no current way to force Wiggle to use another random seed. You cannot force Wiggle to use a random seed with expressions. It only uses the layer number of the layer that you apply Wiggle to. It's designed this way so that every time you duplicate a layer, you get a different Wiggle. And obviously, as we just saw, by adding other layers, we're actually changing the layer number, the layer index, from 3 to 4 in the last case, and that generated different random values. So we had a different Wiggle. So, when you're doing this kind of animation, try to avoid splitting a layer that has Wiggle on it. You're going to get unpredictable results. Let's delete the top version of this. I'm going to drag the endpoint of this layer over to the left, so we've restored our moon layer, so we know that our Wiggle in our comp window is all going to be fine and dandy and all nicely connected together. Instead of splitting the moon layer, let's split the Earth layer. I'm going to go Command up arrow, it'll be Control up arrow on the PC to select our Earth movie, and I'm going to hit Shift page up and page down to find a point in time where we want the layer order to switch. This point looks pretty good for me. I'm about 122, and I'm going to split my Earth layer instead. Command Shift D to split the layer. I'm going to take the first copy, the one that appears here at the front part of the timeline, and drag it behind our moon. It's actually going to change our layer order a bit, so our Wiggle's going to change. But now, the first part of our animation, the moon passes in front of the Earth layer, and in the second part of the animation, the wiggling moon disappears behind it. So, random seeds, very important to understand in Wiggle. If the exact appearance of a Wiggle is extremely important to you, try not to change the layer order to change the index number of that layer, because it will change a Wiggle and may make it from a Wiggle that you like to a Wiggle that you don't like anymore. Okay, I've got one last little thing I want to talk about with Wiggle that comes up from time to time, and that is, how do you wiggle along a single axis of a multi-dimensional property? For example, if we wanted to wiggle just the X scale of our compass layer back here, but not the Y scale. How would we do that? Bring up the scale for the compass, and let's set an expression for that. And you might try at this point to create two separate wiggles within the confines of an array and open a bracket and type in wiggle and then type in some amounts, something like that, and then add the second part of an array. But I'm not even going to waste your time by bringing up the error message right now. That's not going to work. Wiggle affects values that are fed to it. It can't operate on a separate channel of an array like that. You have to do a little bit more work than that. So let me delete that out. And let's go back over to our Acrobat file. We can kind of see it peeking through here, so just switch over to it however you like. And I'm going to hit page down one more time, and that's going to take us to our one-dimensional position wiggle. And I'm going to select the two-dimensional version of this. There's two of them in here. One's for 2 dimensions, one for 3. I'm going to select the two-dimensional version and copy. Let me switch back over to After Effects, go back down and once again set an expression because I deleted it a second ago, and paste. Now, let's take a look at what we just pasted. What we did was set up a wiggle expression just as we did before with wiggle frequency, wiggle angle, wiggle noise. But then we put the wiggle expression itself into a variable. We created a new variable called just. I just want to wiggle in one parameter, so I created a variable called just. Just now contains the wiggle expression that we would have used on the entire property. Wiggle based on frequency, angle, and noise. And we set the frequency and the angle and the noise up here in these variables, right? Well, now that I've done that, now that I have set just as our variable that's calculating the wiggle, I can insert that into our final expression here where I've set up an array. It says position now, but let's change that to scale. We're using the scale value of the initial layer's X parameter. That's what this 0 means. And we're going to use the Y parameter. That's what this 1 in brackets means of what we calculate in our just variable up here. So this simple expression, scale 0, comma, just 1, is going to result in a wiggle of 5 times per second at an amplitude of 45% or so and a noise level of 3. So let's see what that looks like. Well, it looks like a one-dimensional wiggle. We are successfully wiggling along only one axis. We're wiggling 5 times per second. So that's a pretty good explanation of wiggle. And of course, wiggle is only one of hundreds of parameters available to you in expression. So clearly, it would take weeks to get through all of them. But hopefully, by discussing wiggle and random so thoroughly, particularly given how useful they are, hopefully you'll have a little bit of confidence in going in and experimenting with expressions on your own. If you don't think you'll ever get to that comfort level, don't worry. There's still plenty of cool things you can do with expressions that don't involve writing a lot of complicated code. For one thing, you can just copy and paste cool expressions from the library that I gave you, which is what we're going to continue with in our next lesson, Favorite Expressions.